Life is like a redox reaction. Where there is oxidation, there will always be reduction. I mean to say that whenever you want to achieve something in your life, students, you need to sacrifice your comfort zone. So be ready to sacrifice your comfort zone to achieve the success in your life. So hello my shimmering stars, I Shaurya is going to start one short video lecture on redox reaction. Basically, redox reaction chapter is very interesting because we are going to see a lot of structures here, we are going to calculate a lot of things here, and it is very easy also. So students, first of all, we need to understand the very basic term, that is redox reaction. As I told you about the quote, where there is oxidation, there will always be reduction. So if I divide the word redox into two segments, what I will get? Red plus ox. If I divide it into two halves, I will get red plus ox. That means here red refers to as reduction, while ox refers to as oxidation. Now students, as it is clearly seen that it is sum of oxidation and reduction. Now, what do you mean by oxidation or reduction? The question arises in our minds. Students, if I say oxidation is addition of oxygen, so if I define reduction in terms of oxygen, it will be opposite of that. That means removal of oxygen is reduction. Similarly, I can define redox reaction on the basis of hydrogen, on the basis of electrons, on the basis of oxidation number. So, moving forward towards this definition of redox reaction, I would just say that first of all, the very basic thing that we need to understand here is about oxidation number. Then we will come back to this topic and we will define again what do you mean by redox reaction, because to define it, we need to understand a basic term that is known as oxidation number. Now, what do you mean by oxidation state or oxidation number? It is basically the formal charge on any atom. What I am saying is formal charge present on any atom is defined as oxidation state, or you can say oxidation number. Now students, I will give you various examples to clarify what do you mean by oxidation number or oxidation state. If I say Na positive, that is sodium ion. So what is the formal charge on this atom? On Na, it is positive 1, it is plus 1. So here oxidation number that I am denoting by On, okay, is going to be plus 1, right? Similarly, I can take various examples. For example, Mg plus 2. Now Mg is magnesium, right? It has plus 2 charge on it. So the formal charge on that atom represents its oxidation state, represents its oxidation number. So I would say oxidation number is plus 2. Now students, what happens is when we study various compounds, we see that compounds are mixtures of elements, right? Elements are joined together to form compound. Now, in a compound, there are various elements, and to clarify which element has what oxidation number or oxidation state, we need to remember some rules. Some rules to calculate oxidation number for particular element. For example, if I say you, I have HCl. If I ask you, what is the oxidation state of hydrogen or what is the oxidation state of chlorine? So students, you would say that, ma'am, in the first and second example, you told us the formal charge on any atom is its oxidation number, right? So in these in these particular atoms, in these particular species, they were individual. So we could recognize just by looking at this atom. But in the case of compound, what is the problem here is that we need to know at least one atom's oxidation state to find out the oxidation state of another element, right? So to find out oxidation state of one element, at least we should know the oxidation state of another one. So what are the basic rules to calculate oxidation state or oxidation number is our very first topic. So proceeding towards our very first topic, that is rules for calculating oxidation number. Now the very first rule that you need to keep in your mind is that oxidation number for alkali metals, Now what I meant by alkali metals are the elements which are present in group 1, right? So I am writing in the bracket, it's group 1. Okay, and the oxidation number for alkali metals and alkaline earth metals are +1 and +2 respectively. Clear? Okay. Now, what are group 1 elements and what are group 2 elements? As you all have already studied the periodic classification of elements in the victory batch, right, students? So there you have covered alkali metals and alkaline earth metals. That means group 1 and group 2 elements. Still, I'm going to tell you again so that you could recognize them. Now, group 1 elements are okay. Now these are group 1 elements. This is lithium, sodium, potassium, rubidium and cesium, right? So these all students, these all will have oxidation number as +1. Kindly remember that, right? Now if I come forward toward the group 2, okay, now I have these elements, right, students? Now, this is beryllium, then is magnesium, then is calcium, then is strontium, and then is barium. These are group 2 elements. Now, these group 2 elements have oxidation number as +2. So at least you have to keep some of the elements oxidation number or oxidation state in your mind to calculate others oxidation state or oxidation number. So there are basic rules and it will be easy for you to learn this when you are going to practice it out. So don't get confused. Don't think that we have to learn so much of the elements. No, you don't have to learn so much of the elements. Just you need to keep in your mind that these groups have this oxidation number. These particular elements have this oxidation number. That's it. Nothing else. Clear, students? Now this is our first rule. Now coming towards the second rule. The second rule, it states us that oxidation number of elements in their elementary form or native form, in bracket I'm going to write native form, is considered as 0. Now what do you mean by that? What is elementary form? What is native form? If I take an example, you will get it very easily. Now very first example is H2, Cl2, O2, O3, P4, right? So these are the examples that lie under this category. What do I mean by this statement, elementary form or native form? I would say that the form that exists in nature, or I would say that when a particular atom is bonding with the same atom, right? Here if I talk about H2, here hydrogen atom is bonded with another hydrogen atom, right? So same atoms are present. If I talk about Cl2, Cl is bonded with Cl, right? Here what happens is hydrogen is bonded with hydrogen. If I talk about Cl, Cl is bonded with Cl. If I talk about O2, oxygen is bonded with oxygen. So what are you seeing in these forms? That in some of the cases, one of the atom is connected to the same atom. While if I talk about P4, it exists in its elemental form or its native form or in its nature form as P4, right? So these are the examples, or one more you can take is S8, right? So these all have oxidation number as 0. These all have oxidation number as 0. Why, ma'am? What is the reason they are having oxidation number as 0? So now let us come back towards the definition for oxidation number, where I have already told you that, for example, I have this compound HCl. Now, if I have to find the oxidation state for one element, I need to know the oxidation state of another element. So, if I talk, I am having A atom, it is bonded with B atom, right, students? If I say that B atom is more electronegative than A atom, kindly listen it. I said B is more electronegative than A. So what do I mean by that? I meant that I know a single bond holds 2 electrons. We know that a single bond holds 2 electrons. But when I talk about electronegativity, it is the tendency to attract the shared pair of electrons towards itself, right? So if I'm saying B is more electronegative than A, that means both of them are having the 2 electrons in the bond, but the electrons are more shifted towards which atom? Towards B atom. Now these electrons are more shifted, students. These are more shifted towards B. Hence, B acquires partial negative charge and A acquires partial positive charge. Why do we say partial charge or half charge? Because they have bond in them. If the bond is broken, one of them gains electrons and hence acquires negative charge, and one of them loses electrons and gets the positive charge, +1 charge. But here what we see that they hold a bond between them and it is more electronegative. That means the electrons are shifted towards B. Hence they acquires partial charge, because the partial charges combine to form a complete charge, right? So I am saying that here B acquires partial negative because it is electronegative. Why it is electronegative? I am saying we are taking just an example. Electronegative is the tendency to attract electrons. Now when you are attracting electrons, you are attracting the negative charge. Hence B acquires negative charge while A acquires the positive charge. Why A acquires the positive charge? Because electrons are moving away from A, right? So A is here getting partial positive and B is getting partial negative. Now if I talk about HCl, here chlorine is more electronegative than hydrogen. So if chlorine is more electronegative than hydrogen, and we know that HCl holds a single bond between them, so what I will say that chlorine has -1 charge while hydrogen has +1 charge. Are you getting my point? Now, if I talk about the state which I was talking in the rules for calculating oxidation number or oxidation state, I told you there that, for example, hydrogen is bonded with hydrogen. Now, in this case, students, when the atoms are same, there will be electronegative difference or not? Just think once that I am saying when the atoms are different, there the difference in electronegativity arises. But when the atoms are same, there is no difference in the electronegativity. Hence, we say that if the atoms are same, they have 0 charge on them. The individual atoms will have 0 charge because they are bonded with the same atom. Here, there is no difference in electronegativity. Hence, oxidation number is going to be 0 for them. Are you clear with the rule which I was explaining you for the case H2, Cl2, if I talk about O2, O3, or if I talk about the individual atom? Whenever you are looking for an individual atom, for example, individually I'm saying sodium, Na. Only Na is present. That means it has its charge 0. But when Na is written with positive sign on it, then the charge on that atom is recognized as its oxidation number. Kindly understand the basic difference. If the atom is present in its elemental form, in its natural form, for example, I have talked about P4S8, or I have said NaMgAl, like this, without charges on them, then they are considered as zero charge. But if they have particular charge on them, as I told you in the very first rule, like when we were considering about oxidation number, I told you that Na has positive charge, Mg has +2 charge, so their oxidation number will be +1, +2 respectively, right? We considered there before the rules we started, right? So you need to recognize these all in the coming questions as well. Now comes the very next point. The very next point, as we have already covered 2 rules, now here comes the third rule. Oxidation number of hydrogen is taken as +1, except metal hydrides, or you can directly write hydrides. How? Let us see that. I told you, whenever you are going to see hydrogen when it is bonded with another element, you need to take the oxidation number or the oxidation state for hydrogen as +1. But you need to see that whether it is making a simple bond or it is making a compound like a hydride structure. If it comes under the category of hydride, students, then the exception arises. Here is the exception. You need to remember this. So kindly put this in a box, because it is going to help you out. See, whenever you are going to find some exceptions here, your work is to put a star over there so that you can remember in your questions. Now, let us see how I'm talking about hydrides. First of all, let us take an example of HCl. If I take an example of HCl, if I said you that hydrogen basically has +1 charge. So I know the charge of hydrogen. Now I say that calculate the charge of chlorine. How will you do that? See, if I take charge of hydrogen as +1, then I need to sum up all the oxidation numbers for a particular compound, and that algebraic sum is going to be equivalent to 0. Kindly write this characteristic also so that you could apply on this rule as well. Algebraic sum of all the oxidation number present on atoms or present on elements in a compound is equal to 0. But kindly write this condition. But if any compound has a particular charge on it, then its algebraic sum is going to be equal to the charge on the whole compound. Now, I am going to explain both of these cases. First of all, I have told you that first of all, I have told you that algebraic sum of all the oxidation number present on elements. Now, if I talk about HCl, I have hydrogen as an element with me, chlorine as an element with me, right? So both of these have particular oxidation number. Now, when I'm going to add these oxidation number of both of these elements, their sum will always be equal to 0 until there is no charge present on the compound. If there is any charge present on any compound, for example, students, if I take a general case, I say CO3 twice negative. Now see, what do you see here? That this whole compound has a charge 2 negative on that. So here the algebraic sum is equivalent to -2 because the overall charge is -2. But if I talk about what? If I talk about the compound which doesn't have any charge present on it, it's forming just a simple compound. So there what you need to do, there's oxidation number when added, their algebraic sum will be equivalent to 0. So if I take hydrogen as +1 according to this rule, then I need to calculate for the chlorine. So I'm going to take plus. Why I am using a plus sign here? Because I am adding their oxidation numbers. Now, if I want to calculate for chlorine, I need to consider as at an x, right? I'm considering it as x. Now I need to add them. Now this is equivalent to what? This is equivalent to 0. Their algebraic sum is equivalent to 0. So what you will see, this is the basic maths. 1 plus x is equals to 0. Now students, what happens is, whenever you are having a number here on this side and you need to move the number on the other side, the charges get changed, right? So if you have +1 on this side, it is going to be -1 on that side, right? So when +1 is shifted on that side, what we get, x is equals to -1. Hence what we can say, that chlorine has oxidation number as -1. Clear? So when you know the charge of hydrogen atom, you were able to calculate the charge or the oxidation number for chlorine atom, right? So these are the basic rules that you need to keep in your mind. Now comes the exception part, that is the hydride, students. If I talk about hydrides, if I am talking about hydrides, right? So see, in the case of hydrides, example, if I say LiH, lithium hydride, NaH, sodium hydride, these are the examples. Here the oxidation state for hydrogen is not going to come +1. It is going to be different. Now let us calculate according to this rule, the algebraic sums one. Right. I already told you, students, in the very first rule. Now let us come towards the very first rule, that lithium basically has oxidation number as +1. Sodium has oxidation number as +1 because these lie in the group 1 category, right? So now when you are seeing the hydrides here, you have lithium element here and sodium element here, right? So first of all, I'm calculating for LiH, lithium hydride. Now I know that lithium basically has oxidation number as +1. So I'm considering its oxidation number as +1. Now I need to calculate for hydrogen. So I'm writing plus and I'm considering hydrogen's oxidation number or oxidation state as X. Right. Now it is equivalent to what? It is equivalent to 0. Now as I already told you that whenever you are having a number and its charge, it is moving on the another side and the charges get changed. So +1, when it goes on the other side to calculate the value of x, what we are getting, x is equals to -1. That means hydrogen in the case of hydrides has oxidation number as -1. While generally, what I'm saying here, it is taken as +1. Just in the case of hydrides, the situation gets changed, right? Similarly, students, you can calculate for what? You can calculate for the case of NaH. If I talk about NaH, now sodium has +1 charge, hydrogen is taken as X, it is equal to 0 because the algebraic sum for all the elements of their oxidation number, their sum is going to be equivalent to 0. So here what do we get? We get that X is equals to -1. Right, students? So hence we clarify the exception case here. You need to remember in your mind, right? Now students, moving forward towards the fourth rule and the sub part of it, that if any compound has a particular charge on it, for example, this compound has a particular charge on it which is -2, or I would say any of the compound, for example, when you are considering FeCN6 minus 4. This is one of the molecules which you will see in the upcoming examples. Here, what do you see that this is my compound which holds overall charge is minus 4. So here the algebraic sum is going to be what? It is going to be minus 4. It is not going to be 0. Now let us take an example for this only. If I need to calculate here, if I need to calculate the oxidation number for iron, that is Fe. I'm going to tell you once the oxidation number for Cn is minus 1. Okay, just for the sake to let you know the meaning of this point, right? So here, if I know that iron is the oxidation number I need to calculate, so I'm considering it as X. Now I need to add the oxidation number of the another, right? Here another is Cn. Cn has oxidation number minus 1 and they are 6. So I need to multiply this minus 1 into 6. Why? Because 6 are present around this. These are basically the ligands which we are going to study in the coordination compound. We don't have to go so much depth in redox reaction. We just need to calculate the oxidation number. That's it, right? So here, if I talk about iron, I'm considering its oxidation number to be X. Then I'm going to add the oxidation number of the other elements, right? So here the Cn, as I already told you, cyanide has minus 1 oxidation state. So they are total 6. So I'm going to multiply with 6, which is going to be equivalent to 0? No, ma'am. It is not going to be equivalent to 0. Why? Because it has overall charge as minus 4. Right? Now, if I'm going to solve it, X minus 6 is equals to minus 4. As I already told you, whenever I am having a number on one side, I have to move the number on the other side, the charges get changed. So we have to move this minus 6 on that side. X is equals to minus 4 plus 6. Now the charge gets changed. Hence, if I'll calculate it, X will come out to be plus 2. That means that iron's oxidation state in FeCN6 minus 4 is going to be plus 2. So please keep in your mind, whenever the compound holds a particular charge on that, the algebraic sum will be equivalent to that, not 0. Clear, students? Okay. Now moving forward towards our next point, that is the fifth point. The oxidation number for halogens. Now, what are halogens? Fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine, right? Are generally taken as minus 1. So generally, for all the halogens, we take oxidation number or oxidation state as minus 1. Clear, students? Okay, now let's take an example. For example, if I talk about HF. So here, please tell me what will be the oxidation state for hydrogen. So it is very simple. If you are considering hydrogen's oxidation number to be X, now you know that fluorine holds an oxidation number minus 1 generally. So I'm going to add minus 1. Now this will be equivalent to 0. We have already started. So it is minus 1 is going to the next side. Hence it comes out to be X is equals to plus 1. So hydrogen basically has an oxidation number of plus 1 here. Clear? So it is very easy. Generally, when I talk about hydrogen, we are considering it as plus 1. But for the hydrides, it has different concept. It has basically, we need to calculate for those concept, right? For the hydrides. But if I talk about halogen family, they are generally taken as minus 1, students. Clear? Okay. Now comes the next case here. That is the sixth rule. The oxidation number for oxygen is generally taken as minus 2. Now students, it is most important rule. Kindly put a star over here so that you could remember it. I am saying that oxidation number for oxygen is taken as minus 2, but there is an exception. Now, what are the exceptions? We are going to take various examples and we are going to see for the case of superoxides, for the case of peroxides, what is the value for the oxidation number of oxygen atom in it. So students, when I talk about the exception case, the very first case is of peroxides. Now, the example for peroxides are H2O2 or I would say Na2O2, right? Students, now there are various examples. I'm just letting you know that how the oxidation state of oxygen is not -2 in these cases. Let us see. If I say for H2O2, basically what happens is we know that hydrogen has oxidation number as +1. We have already started. So we are going to say take the oxidation state for oxygen as X. So students, for hydrogen, as I already told you, it has +1 charge and there are two hydrogens. So I'm going to multiply it with 2 plus. Here now students, if I'm considering the oxidation state for oxygen as X, I am looking here that basically there are two oxygens present. So that is 2 into X. Now the algebraic sum is going to be 0. What I'm getting is 2 plus 2X is equals to 0. Now this 2 is going to be on the another side and hence the charges get changed. So what I'm getting is 2X is equals to -2, hence X is equals to -1. X comes out to be -1. So what are you observing here is that I told you that oxygen generally has -2, but there are exceptions. For example, in the case of peroxide, there is -1 oxidation number of oxygen. Now, what are peroxides? Basically, here peroxide linkage is seen. Peroxide linkage refers to oxygen is bonded with oxygen atom in such a way. Clear? Okay, students. Now, coming to the next category. Okay, now if I talk about the next category, that is superoxides. That is superoxides. Now, students, in the case of superoxides, one of the examples is KO2. Now, you know that potassium lies under what? Group 1. Sodium, potassium, we have already seen, right? So, sodium basically, here, potassium basically has +1 charge, as it is the element of the group 1, we have already seen. So we need to calculate for oxygen. We know that there are basically 2 oxygen atoms here, so I'm taking it as 2x. The sum is equivalent to 0, hence 1 plus 2x is equals to 0. If 1 is going on the other side, its charges get changed, right? 2x is equals to -1, hence I would say that x is equals to -half. So, for the case of superoxide, the oxidation number for oxygen atom is coming out to be -half. So, this is an exception. Now, the very last exception that we are going to do are oxofluorides. They are going to be oxofluorides. Okay. Now, basically, oxofluorides refers to when oxygen is bonded with fluorine atom. It can be O2F2, it can be OF2. Let us take both of these example. First one is O2F2 and the second one is OF2. Now, students, as you know that we need to calculate the oxidation number for our oxygen atom, right? For our oxygen atom. So I'm considering it as X. Now I have in O2F2 as oxygen atom as 2. So I'm considering as at 2X. Now fluorine is a halogen family member. So it has oxidation number as -1 and I have 2 fluorine that is going to be -2, which is equivalent to 0. Hence here X comes out to be +1. So what I am seeing is that oxidation number of oxygen in this case comes out to be +1. Now students, if I talk about OF2 case, right? If I talk about OF2 case, I am taking again the example of oxygen as an X. Now fluorine is -1. It is multiplied with 2 because there are 2 fluorines. Its sum is equivalent to 0. Here X comes out to be positive of 2 plus 2. So in the case of OF2, the oxidation number for the oxygen atom comes out to be +2. So you can see the variable state for the oxidation number of oxygen atoms. Like generally it basically has, you need to put a box here and a star here because it is very, very important, students. Generally, it has oxidation number as -2, but there are exceptions. For example, oxofluorides, in the case of O2F2, you can see oxidation state for oxygen is +1. For the case of OF2, you can see the oxidation state is +2. For the case of peroxide, you can see the oxidation state is -1. For the case of superoxide, you can say it's -1/2. So you can say variable state for oxygen atom, right, students? These were the rules to calculate oxidation number, oxidation state. I hope you find it interesting, right? Now let us implement all of these in the following questions to make it more interesting, to make it more understandable, so that you can practice it out and it will be clear to you. So students, the very first question here is calculate the oxidation state of the underlined atoms. Now the atoms which are underlined, you need to calculate their oxidation state. Hence, the other elements which are attached to it, you already know according to the rules. What are their oxidation number, right? So if I talk about the very first case, that is CO2. Here I need to calculate for carbon because it is underlined, right? Now, the element for whom I have to calculate, I have to consider it as X, right? So I'm considering the oxidation number of carbon atom as X. So X plus. Now what is the oxidation state for oxygen? Now whenever it is not mentioned to you, so you need to take there as -2, general case of oxygen. So here oxidation number is -2. It is multiplied with again what? 2. Why 2? Because there are basically 2 oxygen atoms present. And according to the rule, the algebraic sum of these are equivalent to 0. So here what do we observe is X. Now -2 into 2 comes out to be -4. X minus 4 is equals to 0. Now this -4 when moves to the other side comes out to be the positive value. Hence it comes out to be X is equals to +4. So students, now, what is the oxidation number for carbon atom in CO2? It's +4, right? Okay. Now, moving forward towards the second case. Towards the second case, students, let us see. Second case is NH2OH. NH2OH, and here we need to calculate for nitrogen atom. Now students, when we need to calculate for nitrogen atom, we are taking its oxidation state as X. Now for hydrogen, we already know the oxidation state is generally taken as +1 +1. So now we are going to add these because their algebraic sum is equivalent to 0, right? So here, how many hydrogens are there? 2 hydrogens and there is one more hydrogen, 3 hydrogen. Basically, +1 is the oxidation state for hydrogen and total 3 hydrogens are there. So I'm multiplying it with 3. And also what I am seeing here is I have an oxygen atom and oxygen's oxidation number is -2. So their algebraic sum is equivalent to 0, right? Now I'm going to calculate it. X plus 3 minus 2 is equals to 0, right? Now X plus 1 is equals to 0. Now students, when I am moving one of the digit to the another side, its charge get changed, right? So now when it is moved to another side, X comes out to be -1. X comes out to be -1. So what do you see here? The oxidation state for nitrogen atom in NH2OH comes out to be -1. Now moving towards the third case. Now you see the very first two cases here were very simple. Why they were simple? Because there were no charge given on the complete compound, right? So in the third case, what you're observing, it already has shown you -2 charge. That means here the algebraic sum is going to be equivalent to -2, students, right? So if I talk about the very third case, which is, one second. Okay, if I talk about the third case, that is SO4 whole charge -2, and I need to calculate for sulfur atom, right? Okay, when I'm going to calculate for sulfur atom, I'm considering its oxidation number as X. I'm going to add the oxidation number for the other elements as well. Oxygen's general oxidation number is -2, and basically there are 4 oxygen atoms, so I'm going to multiply it with 4. And now students, the best part is their algebraic sum will be equivalent to the charge present on the compound. It will not be equivalent to 0, right? So here the charge is -2 present. Now, X minus 2 into 4 is -8. X minus 8 is equals to -2. When -8 is moved to the other side, its charge gets positive. So what we get? X is equals to, sorry for this disturbance, X is equals to 8 minus 2, because on another side it comes out to be positive 8. So what do we get here? X comes out to be plus 6. X comes out to be plus 6, right? So now the sulfur atom basically has oxidation state as +6. Now coming towards our next case, students, let's see the fourth case. The fourth case is Na2O. Here you need to calculate for the oxygen atom. Here you need to calculate for the oxygen atom. It is very simple, students. It is very simple. I want you to solve it first. Till then, I'm going to write these questions here. Solve it very fast because it is very easy for you. Then you are going to match it and it will be easy for you to check where you are doing your mistakes, right? Okay, I'm writing here fifth compound. Till then, when you are solving Na2O2, here also you need to calculate for oxygen. The sixth one is OF2. Here you need to calculate for oxygen. Okay, now coming towards our very first case, students. Let us see for Na2O. Here I need to calculate for oxygen. So I'm taking oxygen's oxidation number or oxidation state as X, and another element is referred to as X. So for Na, I am taking as, sorry, let me clarify you. The oxidation number for whose element we need to calculate is considered as X, and another one is taken according to the rules, right? So here for sodium, we know that it lies under the group 1. So its oxidation number is +1. And there are 2 sodiums, then it is +1 into 2. Now for oxygen, it is X, it is equivalent to 0. So 2 plus X is equivalent to 0. When +2 is taken on the other side, it comes out to be -2. Hence, I would say X is equals to -2. X comes out to be -2, students. So here you have already calculated for oxygen atom. Now let us move towards the next part. For here you also need to calculate for oxygen, but the compound is different. Here it was Na2O, here it is Na2O2. For, you know that oxygen you are considering it as X. For sodium, you know that that it is +1 because it lies in the group 1. And there are 2 sodium, then you need to multiply it with 2, right? Now you will add the oxidation state of oxygen. For oxygen, you are considering it as X, and there are basically 2 oxygen atoms present here. So that is 2 into X. It comes out to be 0. Their algebraic sum comes out to be 0, right? So I would say 2 plus 2x is equals to 0. Now, if I take this positive 2 on the another side, it comes out to be -2. So I will say that 2x is equals to -2. X comes out to be -2 divided by 2. Hence, it comes out to be -1. So X comes out to be -1. So what do you find here? That when we were talking about Na2O, we saw that oxygen has an oxidation state of -2. But when I talked about Na2O2, I saw that oxidation state of oxygen is -1 in this case, right? Now let us see another case. We have already calculated for this case, but let us practice it more, right? So for oxygen, you are again considering it as X. For fluorine, students, you know that it is a halogen family. So it's -1 oxidation state, and basically there are 2 fluorines. Their algebraic sum is equivalent to 0. So what do we see? That X minus 2 is equals to 0. When I am taking -2 on the another side, I am getting the positive value of 2. So what I am seeing this, X is equals to +2. So here the oxidation state of oxygen comes out to be +2. Clear? Okay, now let us move towards the next example, students. Here again you are having the various 3 examples. So I have brought a lot of questions for you. Why I've brought so much questions for you? Because I want you to practice along with me and make your concept a bit stronger, right? Because practice will make you more perfect. Okay, students, if I talk about the seventh question, now We have done a sort of this question in the rule section, but that is a quite different. These are similar, but there is a difference. I'm going to explain how. Let us see. K4 bracket starts FE, then small bracket starts Cn, then is 6, then the square bracket gets closed, right? You need to calculate for Fe, you need to calculate for iron. Now students, what you need to see here is, first of all, whenever you are having any element outside, either add all of these, or you can do, two cases arises here. I am going to explain both of them. First, see, add all of these elements oxidation number, and that algebraic sum is going to be equivalent to 0. Now let us see the case. Both of these will have the same answer. Okay. Now let us see. For potassium, we know that it lies under the group 1, right? So it will have oxidation state or oxidation number as +1. Okay. Now how many potassium? 4, ma'am. So I'm multiplying it with 4, right? I have to calculate for Fe, so I'm considering it as X. Now I'm going to add. Now I already told you in the previous case that Cn has an oxidation state of -1, and there are basically 6 Cn atoms. So I'm going to multiply it with 6, and its algebraic sum is going to be equivalent to 0, right, students? So now what happens here is +4 plus X minus 6 is equals to 0. X plus 4 minus 6 is equals to 0. X minus 2 is equals to 0. Hence, X comes out to be +2. Now, students, this was the first method to do this question. Now, some of the students will consider this question in a quite different manner. How? See, you can also do this question in a very different manner. How? You can say that K4 FeCN6 can also be written as, kindly consider this, FeCN6 whole power -4. So you can either calculate for this or calculate for this. It is a same thing. This I have already calculated in the rule section. Now, how can I write this, ma'am? Please let us know. See, whenever you are making any compound, what do you see? That the positive, lies here and the negative part comes here. So whatever the number lies below this is moved on the charge side, and it comes on the negative part. Like if it is written 2 here, the overall charge for the next atom comes out to be -4, right? If I take an example of this more accurately, I would say water. Let us consider for water, so that I could explain you that. I know that hydrogen has +1 charge and oxygen has -2 charge. I know that. Now if I'm going to make any compound, what I'm going to do is, the charge for hydrogen comes under the oxygen, and the charge for oxygen comes under hydrogen. So hydrogen will have this charge. Now, positive and negative doesn't value here. Okay, you need to just clarify your thoughts that the first atom that you are writing is positive, and the second one you're writing is negative. Hydrogen is positive, oxygen is negative. It is your mind setup, right? So now 2 comes under hydrogen, and under oxygen 1 comes, so it is H2O. Likewise, if I'm going to open H2O, what I will say that this 2 is the charge for oxygen, and the oxygen is written after this, then it has minus charge, and this 1 is the charge on hydrogen, it is written in the front, it has positive charge. Similarly, here what happens is, this is considered as one atom, right? So I would say that this 4 is charged for this, and it is written afterwards, so it has -4 charge. So you can do this question in these two kinds. This I've already told you in the rule section, or you can directly add all of these, and their algebraic sum will be equivalent to 0. Both the cases are right. Clear, students? Now coming towards the eighth question. Eighth question is CH2Cl2. Here you need to calculate for carbon atoms, students. Now to calculate for carbon atoms, see, we are considering carbon atom oxidation state as X. Now for hydrogen, we know that it is already +1, and generally it is taken as +1, and there are 2 hydrogens, so we will multiply it with 2. Plus we are going to add for chlorine. We know that chlorine lies under the halogen family, and its oxidation number is considered as -1. Basically here are 2 chlorine atoms, so I'm going to multiply -1 into 2, students. It will be equivalent to 0, so I will say that X plus 2 minus 2 is equivalent to 0. It will be cancelled out. X comes out to be here 0, students, right? So the oxidation number for CH2Cl2 here for carbon atoms comes out to be 0. Now student, coming towards the next part, that is the ninth question. that is KMNO4. Here you need to calculate for Mn. Here you need to calculate for Mn. Clear? Now students, you already know that potassium has +1 charge because it lies under the group 1, right? So if it has +1 charge, we need to calculate for Mn, so we are taking as at X. Now for oxygen, we know that oxidation number is generally taken as -2, and basically there are 4 oxygen atoms, so I would say that -2 into 4 is equals to 0, right? So +1 plus x minus 8 is equals to 0. X minus 7 is equals to 0. X comes out to be +7. Clear? So for Mn, the oxidation state comes out to be +7. Now moving forward, in the next case, students, let us see. These are very simple cases. Now for the first case, till now we have done all the cases where I would say the algebraic sum is equivalent to 0. Now there are some of the cases where the algebraic sum, you will see, will not be equivalent to 0. It will be equivalent to the overall charge that is present on the atom, right? So if I talk about the 10th example, that is NO3 power -1. Here we are talking about nitrogen. So for nitrogen, first of all, students, you need to take its oxidation state as X. As for the case of oxygen, you know that generally you are taking it as -2, and basically there are 3 oxygen atoms, so you need to multiply. That is -2 into 3. Now the algebraic sum is equivalent to the overall charge present on this. The overall charge is -1, not 0. When there is nothing given to you, you have to consider it as 0. But when you are provided with the charge, students, then you have to consider the charge as your algebraic sum, right? So algebraic sum here comes out to be -1. Now x minus 2 into 3 comes out to be -6. X minus 6 is equals to -1. So when I'm taking this -6 on the another side, it comes out to be the positive value, right? So I will say that x is equals to -1 plus 6. X comes out to be positive 5 plus 5. So here nitrogen has an oxidation state of +5. Now coming towards the 11th case, students, ClO4 -1. Here you need to calculate for chlorine, students. Now we are taking for chlorine as X. Right? Now for oxygen, we know that it is generally -2, and basically there are 4 oxygens. Now the algebraic sum will be equivalent to the overall charge present here, that is -1, -1. Hai na? Now students, x -2 into 4 is -8 is equals to -1. I am going to take -8 on the other side, which comes out to be +8, right? So x is equals to -1 plus 8, which comes out to be +7, students. Now the oxidation state or oxidation number for chlorine in this case comes out to be +7. Now the case arises, which I have already told you, already done in rules. This case we have already done in rules. So hopefully there is no need to solve it again and again, right, students? Moving towards the next part, let us see. These are the last 3 examples to calculate the oxidation state. After the students, we are going to calculate oxidation state, but not with the help of the rules. We are going to calculate the oxidation state with the help of structures. So it will be quite interesting for you. So let us do it very fast here, right? I have again 3 cases with me. Okay. Now the question 13th here is C2O4 overall charge is -2. I need to calculate for the carbon atom, students. Now to calculate for the carbon atom, first of all, I am letting it as X. Now I have carbon as 2. So that will be twice of X. Plus oxygen atoms oxidation state is generally taken as -2, and there are 4 oxygen atoms present here. So -2 into 4. Now their algebraic sum will be equivalent to what? The overall charge that is present on the atom, and the overall charge present on this atom is -2, students, right? So here it comes out to be 2x -2 into 4 is -8 is equals to -2. Let us take this -8 on the another side, which comes out to be +8. So what do we get here is 2x is equals to -2 plus 8, which comes out to be +6. 2x is equals to 6, hence x is equals to +3. So what do I get here? Carbon's oxidation state is +3 in this case. Clear? Okay. Now moving forward towards the 14th question. 14th is CrO4 minus 2. I need to calculate for Cr. Now, to calculate for Cr, first of all, I have to take it as X. Now, for oxygen, I already know it's minus 2. Basically, there are 4 oxygen atoms, so I'm multiplying it with 4. And the algebraic sum will be equivalent to the overall charge present here, which is minus 2 students. Right? So, X minus 8 is equals to minus 2. Let us take this minus 8 on the another side. Minus 2 plus 8, X comes out to be plus 6. So its oxidation state comes out to be plus 6. Now coming forward towards the last part of this topic, that is our N2O3. Now I need to calculate for nitrogen atom, students. For nitrogen atom, I am considering it as X. I have 2 nitrogen atoms, so I am taking it as 2x, right? Now I'm going to add the oxidation state of the another element, which is oxygen, which I am taking generally as minus 2. Basically, there are 3 oxygen atoms, so we are multiplying minus 2 into 3. Their algebraic sum will be equivalent to 0 because there is no charge given to us on the compound, right? So here 2x minus 6 is equals to 0. Let us take minus 6 on the another side. It comes out to be positive 6. Hence, x comes out to be plus 6 by 2, which comes out to be plus 3. So here x comes out to be plus 3, students. So the oxidation number here for nitrogen comes out to be positive 3. Clear, students? So students, this were the questions based on the rules for calculating the oxidation number or the oxidation state. Basically, oxidation number or oxidation state can be calculated by 2 basic methods. That is, first the formula, which we used according to the rules. Second one is the structures. What happens is, whenever you are calculating oxidation state, in some of the questions, you find that oxidation state for some of the cases comes out to be fractional value. Now, what is that fractional value? That fractional value is basically the average oxidation number. Now, for some cases, it doesn't come out to be fractional value, but some are exception. You need to draw the structure. Whatever you are calculating in the rule section comes out to be different value when you are observing in the structures. So that exception cases, I'm going to explain you in the structure part. So now we are going to do our next part, that is, we are going to start our calculation of oxidation state from the structures. So our first structure that we are going to do is a CrO5. Okay, students, now what we need to do is, for calculating oxidation number or oxidation state with the help of structures, we need to draw the structures. Now I am taking only the exception cases so you can easily learn the structures, and once you know how to draw them, you will be easily to understand the basic difference that calculating from the rules and calculating from the structures. Right? So if I talk about CrO5, first of all, we need to see the central atom here. The central atom here is Cr. Right? It is bonded with 5 oxygens. Now O5 refers to as, here is a double bond oxygen present, here is another oxygen, here is another oxygen, here is another oxygen, and here is another oxygen. Now students, to let you understand what will be the charge present on this Cr atom, the central atom, see, what we need to do is, as I have already told you in the previous case, that whenever I have 2 atoms A and B, if B is more electronegative than A, then what happens? B acquires the negative charge, right? And A acquires the positive charge. This is what we get. It acquires partial negative, it acquires partial positive. Same is the situation we are going to see here. Now, if I talk about chromium or if I talk about oxygen, the electronegativity thing, I need to see here, the oxygen is more electronegative. Hence, it will acquire negative charge and the chromium will acquire the positive charge. Now, students, what happened here is, one bond will give one charge, 2 bonds will give 2 charge. Now you need to identify when you are getting positive charge and when you are getting negative charge, right? So if I talk about chromium here, what I'm observing is, this is the first bond, this is the single bond, right? So oxygen is electronegative, it is getting -1 charge, and due to oxygen as it is electronegative, chromium is getting +1 charge due to this bond because it is a single bond, right? If I talk about this bond again, it is a single bond, 1 bond, so it is getting -1 charge, it is getting +1 charge. If I talk about this bond, it is getting -1 charge, it is getting +1 charge. If I talk about this bond, it is getting -1, it is getting +1. Now comes the double bond scene. Now there are 2 bonds, then the number will be 2. 1 bond holds 1 number, 2 bond holds 2 number, 3 bond holds 3 number. Now see here, these two basically are the 2 bonds. Oxygen is more electronegative, it is getting -2, hence Cr is getting +2. Now we will add its oxidation number. Now See, +1, +1, +1, +1, +2. This is the overall oxidation number on the chromium. It is 1 + 1 + 1, 4. 4 + 2 is 6. So, chromium's oxidation number comes out to be +6. It comes out to be +6. So with the help of structure, you can easily understand this, right, students? Now we will move forward towards our next structure. Now let us see the next structure. It is HO2F. HO2F basically, here how you will represent it, it is very simple. You will see that there is hydrogen, then it is bonded with oxygen, it is again bonded with oxygen, it is further bonded with fluorine. Now again you need to see the electronegativity difference. That will help you to find out the charges on them. Now student, if I see oxygen, first of all we are taking these two cases, hydrogen and oxygen. I know that oxygen is more electronegative than hydrogen, so I see that both of these hold a single bond between them. So oxygen will have which charge? It will have -1 charge, it will have +1 charge. Now coming across these two both, I already told you, when an atom is bonded to the same atom, both of these will acquire 0 charge. So this oxygen will hold 0 charge on this, and this oxygen will hold 0 charge on this, because they are the same elements. Okay, now moving towards the next bond, that is the oxygen fluorine bond. Now students, if I talk about oxygen fluorine bond, I know that fluorine is the most electronegative atom in the periodic table. Hence I will say that fluorine acquires which charge? -1 charge, and this oxygen will acquire +1 charge in this bond due to this fluorine. So what I am seeing here, that one of the oxygen is getting -1 charge, another one is getting +1 charge. So when you were calculating according to the formula, if I ask you to calculate the oxidation number for oxygen, you took hydrogen charge as +1, plus for oxygen you took as X, and there were 2 oxygens, so you took 2X. For fluorine you took -1. The algebraic sum was 0. You did 1 + 2X -1 is equals to 0. This will cancel. You said 2x is equals to 0, x is equals to 0. You said that oxygen hold 0 charge, but actually when you draw the structure, what you observed, that one of the oxygen is having +1 charge, another one is having -1 charge. So what is this thing now? This is basically the average charge of these oxygen atoms. Now both of these, if I calculate average charge, what will be the average charge? One of them has -1, another one has +1. Now I'm talking about these two both, so it will be divided by 2, because I'm talking about 2 compounds, 2 elements. Not compounds, elements. So it comes out to be 0, students. So this 0 basically, which we calculated according to the formula, was actually the average charge, not the formal charge on an atom. On an atom, the formal charge came out to be -1 and +1 respectively. So the structures, they are so interesting. When we draw, we get to know a lot of things here, right? Now coming across the next question, that is CaOCl2, students. Now let us see for this case. Now students, let us see their structure. Now Ca, then is O, then is Cl, and another Cl is bonded like this. So basically this is the structure. Now we need to calculate the oxidation state for all the elements. Now see students, one by one we are going to see the bond. First of all, let us see for oxygen and chlorine. I know that oxygen is more electronegative. Basically what happens here is oxygen is more electronegative than chlorine, right? So if I see here, if it is more electronegative, then it acquires -1 charge, it will acquire +1 charge, right students? Now if I come across this bond, calcium and oxygen, again I know that oxygen is more electronegative and calcium is less electronegative, students. So it will have again -1 charge due to calcium and +1 charge due to oxygen on this. So hence here oxygen basically has how much charge? -2 charge. Here overall charge for oxygen comes out to be -1, which is -2, right? Now if I come across this bond, students, what happened here is chlorine is more electronegative than calcium, so I would say -1 charge arise here and +1 charge arise here. So here again for calcium, the overall charge comes out to be +2. Clear? So here the individual charges are in front of you. Like for chlorine, you can see the +1 charge for when it is bonded with oxygen, and here it has -1 charge, while calcium has +2 charge and oxygen has -2 charge. Clear? So here chlorine lies in 2 states, that is +1 and -1 respectively. You can see in the following structure. So students, now let us see the next case. Next case is Fe Fe3O4. Basically, Fe3O4 is a combination of two oxides, students. You can't find the oxidation state for Fe directly. If I find according to the rule, what I will say is that if Fe holds an oxidation state as X, how many Fe are there? 3. So 3X plus oxygen has -2. How many oxygen? 4. Algebraic sum is equals to 0. 3x minus 8 is equals to 0. X comes out to be 8 by 3. This comes out to be the oxidation state if I calculate according to the formula. But students, as I told you, they exist in the form of two oxides. One of the oxides is FeO. It exists as FeO. So for FeO and for Fe2O3, you will calculate individually Fe's atomic number. Now, if I talk about FeO, here students, let us take it as X, and I know that oxygen is -2, which is equivalent to 0. So here X is +2. And here Fe's charge, let us, that there are 2 Fe. So 2X plus oxygen as -2. There are 3 oxygens. Its sum is equals to 0. 2x minus 6 is equals to 0. 2x is equals to 6. X is equals to +3. So here Fe holds an oxidation state of +2, while here Fe holds an oxidation state of +3. So basically the sum which we are calculating according to the rule is the average, oxidation state. It is not the formal charge on particular Fe, because if I talk about particular Fe, the formal charge comes out to be +3, students. It comes out to be +3. How we calculated average? I will let you know that also. See here, students. If I say for FeO, Fe has +2 charge. For Fe2O3, Fe has +3 charge, and basically there are 2 Fe's. So it will be multiplied by 2. And how many Fe are there? 1 and 2 are present here. Total 3 are present. So average comes out to be 2 plus 6 by 3. That comes out to be 8 by 3. So this 8 by 3 is basically the average charge. So if they are talking about the formal charge in the question, then you need to tick mark on +2 and +3 respectively, not 8 by 3 when they are talking about formal charges. But then when they are talking about average charges, then you can directly calculate it, right, students? Okay, now proceeding towards our next question. So students, if I talk about the structure for this, first of all, we need to mention Cr here. Then it is bonded with oxygen in such a way which is further attached to OK. O and potassium, O and potassium further. Here it is bonded in such a way. Clear, students? So this is basically the structure for this. Now we need to find the oxidation states respectively. So if I talk individually, if I take oxygen and potassium here, I know that oxygen is more electronegative. So it will acquire -1 charge and it will acquire +1 charge. Now moving towards these two, both these two are same elements. So they both have no impact on each other. Hence there is nothing for both of these cases on each other. Now coming towards this case, I know that oxygen is more electronegative and hence acquires negative charge, while Cr due to this bond will acquire +1 charge. Now coming to these things, these are almost similar. So it will +1, -1, +1, -1. -1, -1, +1, +1. Now please don't get confused. This negative -1 is due to potassium and this negative -1 due to chromium. Okay, clear, students? Now if I talk about these, here it is -1, it is providing it +1. Here it is -1, it is providing +1, and both on each other is giving no oxidation state because they are same atom. So if I talk about chromium here, students, chromium here, it has 1 + 1, 2, 3, 4, 5. Basically its oxidation number comes out to be +5. Clear, students? So these were the cases when we understood oxidation state, oxidation number on the terms of structure. Now we have understood oxidation number, oxidation state very in depth, right? Now we are moving forward. Our next segment that comes out to be the redox reaction. As I told you, to define redox reaction, we need to learn first the oxidation number, which we have already covered. Now the theory portion, a little bit theory portion starts. What do you mean by redox? As I already told you in the starting, redox basically is sum of reduction and oxidation. The life is just like a redox reaction, right, students? Where there is oxidation, there always be reduction. You know na? So here oxidation can be defined according to certain terms. If I talk about the in terms of oxygen atom. If I say in the terms of oxygen, I would define oxidation as addition of oxygen. Addition of oxygen. And reduction in terms of oxygen will be defined as a removal of oxygen. Removal of oxygen is reduction. Now let us take some examples for this to understand more clearly, students. So if I talk about addition of oxygen, one of the example is Mg plus O2. It gives out to be MgO, magnesium oxide, and we need to balance it out also, students. So here 2 will come, here 2 will come. Right, this is one of the example. Another example is CO2 formation, that is carbon plus O2, it gives us CO2. So this is addition of oxygen. So whenever there is an addition of oxygen, it comes under the category of what? Oxidation. Now if I talk about reduction, reduction basically refers to as the removal of oxygen. Now whenever I am talking about removal of oxygen, we can take certain cases here also, students. If I talk for example, copper oxide. Let us take an example for copper oxide. When it is treated with carbon, students, basically what we are getting copper and carbon monoxide. Clear, students? So here what are you observing is that oxygen is being removed. Oxygen is being removed from CuO, right? Right? So this comes under the category of what? It comes under the category of reduction, ma'am. It was the simplest example. Another example which we could take is water plus carbon. Water plus carbon basically gives us what? CO plus H2O. Right, students? This was the reaction when removal of oxygen takes place. Let me take some water, students, so that we could start further, right? Okay. Now, students, coming towards the next definition for oxidation and reduction. Okay, now I will define oxidation and reduction on the basis of hydrogen. If I say here there is addition of oxygen, so here will be removal of hydrogen, the opposite of this, right? So if I say removal of hydrogen, it is also referred as oxidation. And if I say addition of hydrogen, it is referred to as reduction. Addition of hydrogen. Addition of hydrogen. Clear, students? Now let us take some of the examples here. First of all, let us take an example for addition of hydrogen. For example, if I say H2 plus Cl2, it gives us HCl. So this is one of the most common example which you could easily tell us. Another example you could take is sulfur plus H2, it gives us H2S. Clear, students? Now, students, if I talk about removal of hydrogen, I will take an example of H2S plus Cl2. It gives us HCl plus sulfur. So what do you see here? You see here that there is a removal of hydrogen. How hydrogen is removed? It was first attached to sulfur, so it is removed here. You can further balance it out, that's not a big deal, but you can see the removal of hydrogen in the case that first it was attached with sulfur, it was bonded with sulfur, then it is removed, right? It is removed. Or you can do that water splits out into H2 plus O2. You can take further examples also. These were the basic two things that we got to know in the basis of oxygen and hydrogen. Now, students, if I talk on the basis of electrons and oxidation number, what will be those examples? Let us write that. If I say on the basis of electrons, on the basis of electrons, we will define oxidation and reduction. Now, see, most importantly, that they will ask you in examination will be on the basis of oxidation number, because that is the basic criteria for redox reaction. But these are important because sometimes when they are talking about redox reaction directly, then you need not to calculate oxidation number. It will be lengthy process. You can directly see the addition of oxygen, the removal of hydrogen, and you can easily identify. So if I talk about the loss of electrons, it comes under the category of oxidation, right? So if I talk about loss of electrons, so that is oxidation, and students gain of electrons is reduction. Gain of electrons is basically a reduction process. Now let us take an example. Sodium, it splits into Na positive and one electron is liberated out, right? Similarly, you can take an example for Zn. It splits out into Zn plus 2 and 2 electrons are liberated. So here electrons are lost, students. So whenever there is a loss of electron, it is referred to as oxidation. Now if I talk about the reduction process, now for the case of reduction process, we say that gain of electrons. If I say Cl2, if I add 2 electrons in it, what I'm going to get? I'm going to get 2 Cl negative. So basically this is the gain of electrons case, right, students? So now students, this was on the basis of electrons. Now I'm talking on the basis of oxidation number. On the basis of oxidation number. Oxidation number. So students, when I talk about oxidation number, if I say there is a gain of oxidation number, there is an increase in oxidation number, that is oxidation. When there is a decrease in oxidation number, that is reduction. We are going to follow this a lot in the coming examples in balancing the chemical equations. We are going to follow this, so please kindly understand this and also put a star mark over here because it is the most important, right? Okay, now students, what I'm going to tell you, that on the basis of oxidation number, how can I define it? Let us take an example. Na splits into Na positive. Now students, as I told you, when any atom is present alone, that means in elemental form or it's in free state, its oxidation number is considered as 0. And whenever there is any ion given, the charge present on that is considered its oxidation number. So for here, oxidation number is 0 and here it is plus 1, right? So from 0 to plus 1, what we will say that from 0 to plus 1, the oxidation number is increasing. So now the oxidation number is increasing here. It is increasing here. So whenever it is increasing, students, increase in oxidation number, it is refers to as oxidation. Okay, now let us take an example for the reduction process also. For reduction, we would write decrease in oxidation number. I would take the same case over here. You can directly see the same case you can take, or you can take another case. For example, Fe plus 3 plus electron gives Fe plus 2. Let us take this case. Here there is positive 3 charge. Here it is plus 2 charge. So plus 3 plus 2 charge is being reduced. It is being decreased. Hence, I would say decrease in oxidation number is reduction. So students, now we have came across oxidation and reduction separately. We have found them, and whenever these two both are seen together, they are referred to as a redox reaction. They are referred to as redox reactions. So before going to this, let us come to the very first page of our PDF where we have started our topic redox. Now I'm going to give you some of the examples here. So kindly mention this. When oxidation and reduction are seen or observed in any reaction, they are referred to as redox reaction, right? Any reaction, or they occur simultaneously, I would say, they are referred as They are referred as redox reaction. Let us take some few examples over here to understand it more clearly, students. Okay. Now, students, I am taking one of the simplest example, that is SN. Now, students, here SN has +2 charge. It is reacting with Fe +3, which is giving us SN +4 and Fe +2. Clear? This is our reaction. Now, how to identify here that oxidation and reduction both are taking place? Kindly see the oxidation number change. See, from Sn is converted from Sn +2 to +4. +2 to +4. The number is being increased. Hence, I would say oxidation number increases. Hence, it is referred as oxidation. Right? Okay. Now here, if I see Fe +3 is being converted into Fe +2, from +3 to +2, charge decreases or oxidation number decreases. I would say oxidation number decreases. Now, when oxidation number decreases, it is reduction, students. So you would be clearly understand this example, right, students? Okay, now I am proceeding towards our question. Let us see this question which I am having here with us. Which one of the following is a redox reaction? You need to tell me which of the following is a redox reaction. The very first is H2 plus Br2 gives 2HBr. The next one is 2NaCl plus H2SO4 gives Na2SO4 plus HCl. The very next is HCl plus AgNO3 gives AgCl plus HNO3. The next is NaOH plus HCl gives NaCl plus water. So students, the basic thing that we need to remember is oxidation state. That will be very easy for us. See, H2 is present, hydrogen is bonded with hydrogen, so its oxidation number is 0. Again, bromine is bonded with bromine, its oxidation number is 0, right? Here I know that for hydrogen we take as +1 and bromine comes under the family of halogen, it is taken as -1, right? Now let us see. H2 is being converted into, hydrogen. So here, from 0 to +1, oxidation number is being increased. When oxidation number, I am writing with ON, is increased, it is referred to as oxidation. Okay, and if I talk about from Br, from 0 it is coming to -1, that is being reduced. So here oxidation number is decreased, and when it is decreased, it is referred to as reduction. So students, whenever we see oxidation and reduction in a particular reaction, it is referred to as redox reaction. So the A option is directly our correct answer, but still I'm going to explain you the further options also for your easy understanding, right? If I talk about the second example, let us see. Na has +1 charge, we know that it is the group 1 element. Cl has -1 charge, right? For H2SO4, I know that hydrogen basically has +1 charge, right? And this whole group is having -2 charge, right? Similarly, if I talk about here, Na will have +1 charge and this whole group is having -2. Here it is having +1, it is having -1. So if you see, all the charges are same. Na here is +1, here is also it is +1, here it is Cl is -1, here it is also -1. So there is no increase or decrease in oxidation number. So here it is not a redox reaction, it is general reaction, it is not a redox reaction. If I talk about C option, here you can see that here hydrogen has +1 charge, Cl is -1. Now here if I talk about Ag, it is having +1 charge, this whole is having -1 charge. Here Ag is having +1 charge, Cl is having -1 charge, it is having +1, this whole is having -1. So here again there is no increase or decrease in oxidation number, hence it is not any redox reaction. Now if I talk about the last example here, again Na has +1 charge, OH has -1 charge, HCl, H has +1 charge and Cl has -1 charge, Na has +1, Cl has -1, hydrogen has +1, oxygen has -2 charge. So if you see in all these cases, if you individually see, the oxygen will be having -2 charge, right? So if you see here also, there is no increase or decrease in oxidation number, hence it is also not an redox reaction. Only in the first case we are seeing that there is an increase in oxidation number, so it's oxidation. Here is a decrease in oxidation number, so it is as reduction. Clear? So like these questions you will see in your questions in your paper. So now comes our next topic, that is refers to as oxidizing agent or reducing agent. Basically student, it is a topic which a student gets confused. Just you need to remember this: oxidizing agent is the one that is being reduced, okay, which is being reduced. It is just the opposite. And reducing agent is the one that is being oxidized. That is being oxidized. I will explain you with the help of question so that it will be easy for you to understand. Just remember this, that reducing agent will be the one that is being oxidized and oxidizing agent will be the one that will be reduced. So first of all, you need to find out what is being reduced and what is being oxidized, right? In which oxidation is taking place or in which reduction is taking place. So this you have in case phosphorus plus NaOH gives PH3 plus NaH2PO2. Now students, first of all you need to write the oxidation number for all the elements individually. So it is present in its individual state. Here the oxidation number will be 0. I know that sodium basically lies in the group 1, so it has +1 oxidation number. Oxygen has -2, hydrogen has +1. Here again, if I calculate for, for phosphorus, if I need to calculate for phosphorus, what is the method to calculate? I would take it as X, right? For hydrogen, I know it is +1 into 3 is equals to 0. I would say X is equals to -3. So it has -3, hydrogen has +1 charge, right? If I talk about here phosphorus, so I would say sodium has +1 charge. Hydrogen has +1, it has -2. So how I will calculate? +1 plus 2, y 2, 1 into 2 plus x. Now plus oxygen is -2 into 2 is equals to 0. I would say 1 plus 2 plus x minus 4 is equals to 0. 3 plus x minus 4 is equals to 0. X minus 1 is equals to 0. X is equals to 1. So here phosphorus is getting +1 charge. Now what you are seeing here is only phosphorus is the one that is being converted from 0 to -3 and that is being converted from 0 to +1, right? Other elements you can see all of these have same oxidation numbers, right? So what I'm seeing that phosphorus is the one that is showing us water reduction because the oxidation number is being reduced, and phosphorus is the one that is being oxidized. The oxidation number is increased. So phosphorus here is oxidized as well as reduced. So option C will be our correct answer. Clear students? Here I wasn't able to tell you the oxidizing agent, reducing agent. No worries. In the upcoming questions you will be easily see that oxidizing and reducing question. Here is the question. See, you have this reaction with you. H2O plus carbon gives CO plus H2. Right students, here first of all write the oxidation number to understand it nicely. So here I know that hydrogen has +1 charge, oxygen has -2 charge, right? Carbon has no charge because it is present individually, elemental form, so it is 0. So if I talk about carbon here, so I know that oxygen is -2. If oxygen is -2, carbon's oxidation state comes out to be +2. How? See, if I'm taking it as X, I know that oxygen is -2, it is 0, X comes out to be +2. So I directly wrote +2 here, right? So here H2, when hydrogen is bonded with hydrogen, it comes out to be 0. Now what do you have to see here is where is oxidation taking place and where is reduction taking place. So if I see hydrogen is moving from +1 to 0, that means oxidation number is decreased, from +1 to 0 it is being decreased, hence it is reduction. Okay. And carbon, if you see from 0 to +2, it is being increased, it means it is oxidation. Now this much you can do very easily. But we need to find something else. What we need to find is, we need to find the reducing agent or the oxidizing agent, right? So if I see the D option, it shows reduction and oxidation does not occur, but it is occurring. So D is directly wrong, right? We have only three options left with us. As I told you, the one that is doing the oxidation is known as reducing agent. Now, the carbon is responsible for oxidation, hence carbon is referred to as reducing agent. And here H2O is doing reduction, hence it is referred to as oxidizing agent. So it is directly opposite, students, right? So if I talk here, if I see H2O is a reducing agent, no, it is an oxidizing agent. So this is wrong. B option is H2O is an oxidizing agent, right? B option is right. C option is carbon is the oxidizing agent, no, it is the reducing agent. Clear? So option number B will be our right answer. Answer will be option number B. Clear? Now we will move towards our next topic. Very simple and interesting topic, that is types of redox reaction. Basically, students, redox reaction can be classified in such a way. One of the kind is combination reaction. The second kind that you're going to study is disproportionation reaction. The next kind that you're going to see is decomposition reaction. The very next kind is displacement redox reaction. And the last two are intermolecular reaction and intramolecular reaction. Some of the reactions you have already covered in your 10th standard, but don't worry if you haven't studied there. I'm going to explain all of these reactions again. Right? So when you have started studying chemistry, you studied about reactions. In those, I am telling you, you have already seen what are decomposition, displacement, combination. You know all these names, right? But one by one we are going to focus on them. First of all comes the combination reaction. Now, what do you mean by combination reaction? As the name suggests, something means to combine. Here you need to combine something and a product is going to be obtained by the combination. So what I will say when I'm going to define this, when two reactants combine with each other to form product, it is referred as combination reaction. For example, if I say A reactant is reactant with B and it gives us a single product, which is C. Here single product is basically obtained. Generally it is seen that. Now let us see some of the examples here. Example, Mg plus O2 gives us magnesium oxide, that is MgO. You can directly balance it out also, students, right? Clear? Another example, carbon plus O2 gives CO2, students. Clear? So now in combination reaction, as the name suggests, something is being combined and giving us a single product. Clear? Okay, now moving forward towards the next type, that is disproportionation reaction. What do you mean by disproportionation reaction? When a single element of a single compound is responsible for oxidation as well as reduction, right? So you will write when single element in single compound is responsible for oxidation and reduction. It is referred to as disproportionation reaction. One of the example we have already seen, but I'm going to explain you again. P4 plus NaOH. We have just seen in the following questions. It gave us pH3, right, student? It also gave us NaH2PO2, right? Now you can already see here, if you write the oxidation states, it has 0, it has +1, it has it has -2, it has +1. This we will calculate x plus 3 is equals to 0. X comes out to be minus 3 here. Here for phosphorus, it comes out to be plus 1. We have already calculated in the upcoming question. So what we see here is 0 to minus 3. It is being reduced. Oxidation number is decreased. 0 to plus 1. What are we seeing here? It is being oxidized. So here a single, element is responsible for oxidation as well as reduction. Clear, students? Now coming towards our next type, that is thermal decomposition reaction. Now what do you mean by decomposition? To decompose, to split, right? So when a compound splits into two or more than two types, it is known as thermal decomposition reaction. When compound splits into two or more than two product, basically it decomposes, right? So that is decomposition reaction. For example, A splits into B and C, so we get the product B and C. Example, if I would take as of water is split into H2 plus O2. Clear, students? Now a single compound is splitting into two compounds, so this is an example of thermal decomposition reaction. Now coming towards our next case, students, if I consider the next one, that is displacement reaction. Now as the name suggests, displacement means to displace something, to take place of something, to replace it, I would say. Okay, so displacement reaction is when one element of one compound displaces another element of another compound It is referred to as displacement reaction. Students, if I take an example, general example, I would say XY plus AB. Now what happens here is Y is being displaced, right? So here it comes out to be XB plus AY. Similarly, when I'm taking off two cases, I can take off a single also, like X plus AB. Here XB plus A is produced. You can do in the similar manner also, students. So this was about displacement reaction, students. Now students comes the next category, that is intermolecular and intramolecular. Intermolecular and intramolecular are very simplest, and there is also very easy case for you to understand with the help of an example. If I talk about intermolecular reaction, students, I would take a case of SnCl2 plus FeCl3. Okay, now it is giving us SnCl4 plus FeCl2, right? Let us write an oxidation number here for you to understand. If I'll calculate for Sn, it is X plus. Chlorine has -1 oxidation state. There are two chlorines. The algebraic sum is equal to 0. X comes out to be +2. So here Sn is in +2 state. Now let us calculate here also. Let us take it as X. Now for chlorine it is -1. There are 4 chlorines. Algebraic sum is 0. It comes out to be +4. Now see, Sn is moving from +2 to +4. What do you see here is from +2 to +4, right? So here oxidation occurs in this case. Now students, if you see another thing, what happens here is, if I talk about FeCl3, for the case of FeCl3, let us calculate for Fe. X plus chlorine has -1. Basically, there are 3 chlorines. Algebraic sum will be 0. So it will be +3. Here, Fe is in +3 state. And if I calculate here, X plus chlorine has -1. 2 chlorines are present. X comes out to be +2 +2. So what do you see here? It is moving from +3 to +2. That means reduction is taking place. So what do you see here? Different compounds are responsible for oxidation and reduction. Like this compound is doing oxidation, this compound is doing reduction. So different compounds are doing oxidation and reduction. That is intermolecular reactions. And the last category that comes out to be intramolecular reactions, students. For intramolecular reactions, it is somewhat related to disproportionate reaction. Don't get confused in both of these cases. Let us take an example, KClO3. Basically, KClO3 is split into KCl plus O2. Now students, let us see here what happens. Here what happens is, if I talk about potassium, it is +1 charge. Let us calculate for chlorine first. For potassium, it is +1. Chlorine, we are taking as X. For oxygen, we know that it is -2. 3 oxygens are present and the total algebraic sum is 0. So 1 plus X minus 6 is equals to 0. X minus 5 is equals to 0. X comes out to be +5. So here chlorine is in +5 state, oxygen is in -2 state. Here if I talk about potassium is +1, chlorine is -1 and it is 0. So what do you observe here? Students, kindly see this, chlorine is moving from +5 to -1 state, while if you talk about oxygen, you see it is moving from -3 to 0 state, -2 to 0 state. So what do you see? A single compound is responsible for what? A single compound which have different elements. Here single compound have different elements which are undergoing reduction and oxidation. In disproportionate reaction, what have we seen? In disproportionate reaction, a single element was doing oxidation and reduction. But what here we have seen? Here we have seen is that a single compound has different elements which do oxidation and reduction, means that a same compound is responsible for this, and in that case that a single element is responsible for both of these cases. Clear? Okay students, now let us see one of the examples here. Okay, if I talk about this example, which of the following example does not represent disproportionation? Now again, let us see first case here. If I talk about first case, MnO2 plus HCl gives MnCl2 plus Cl2 plus water. So first of all, for Mn we need to calculate Mn's oxidation state. Let us take it as X, plus oxygen is -2. Basically there are 2 oxygen is equals to 0. X comes out to be +4. That means Mn is in +4 state. Let us calculate here also Mn's state. It's X plus chlorine is -1 into 2, it is 0, it comes out to be +2, right? If I talk about oxygen, it is -2, and if I talk about oxygen, it is -2. You remember disproportionate reaction was the one in which one element is responsible for oxidation and reduction, but here if you see, what are you going to see? Here you are seeing that here it is doing reduction, while here in this another compound is responsible for oxidation. So different compounds are responsible for oxidation reduction, but we need only a single element for oxidation and reduction, so that is not possible in this case. So A is not the option. Now let us see the B case. Here we see that in H2O2, students, hydrogen occupies the +1 charge, while oxygen, as we'll calculate for oxygen, hydrogen has +1, 2 hydrogens, so 2 plus 2x is equals to 0, hence it is -1 charge. So if I say it is 0, it is -2 and it is +1. So here single element, oxygen is showing, oxygen is showing two different state. It is being reduced as well as it is being oxidized. So here a single element is responsible. So this is our answer. Answer B is exact for this case, is appropriate for this case. Why? Because a single element is doing oxidation and reduction, as we have seen in the case of P4. Clear students? So hopefully this is clear to you, the types of reactions. Now the most important and the portion from which the question arises every time in your examination is the balancing part. So basically students, now we are going to start balancing of a redox reaction. Kindly put a huge star here, because it is the most important, I would say the most important topic for your examination, and this holds basically two methods. One of the method is ion electron method, with the help of which you can do balancing of a redox reaction. Another one is the oxidation number method. So both of these are very important. One by one we are going to start and we are going to balance a redox reaction. So let us move forward towards the first kind, that is oxidation number method. So students, now let us start with our first method, that is oxidation number method. So students, oxidation number method is basically when we are taking everything in terms of oxidation. When I'm talking about ion electron method, then I'm considering electrons in that case. So here, first of all, what you need to do is, whenever you are given a particular reaction, you need to convert that chemical reaction into chemical equation. For example, in any of the question, it is given to you hydrogen plus oxygen gives water. So you need to convert it into chemical equation. For example, H2 plus O2 gives H2O, like this. Okay, so for the first case, I would say that the very first case tells us write the skeletal equation for the reaction. Clear? The second most thing that you need to keep in your mind is write the oxidation number on each atom in a reaction. Now we know how to mention the oxidation number, how to calculate the oxidation number. So you need to write. It is the most important part. The next thing is identify which of the following is where oxidation occurs and where reduction occurs. First, you need to write the equation. Second, you need to write the oxidation number. Third, you need to write where is oxidation taking place and where is reduction taking place. After that, students, the most important thing that you need to keep in your mind, find out the change in oxidation number. You need to find out the change in oxidation number. I am highlighting it so that you could easily remember it. You need to find out the change in oxidation number. For example, if I say the first oxidation number was +4, now it is converted into +2. The oxidation number changes 2, right? I'm going to explain in the various examples. Don't get confused. Balance the atom undergoing oxidation and reduction. After that, you need to do balancing. First of all, you are going to see the oxidation number, then you are going to recognize where is oxidation, where is reduction, then you are finding out the change, and then you are balancing the atom that is undergoing oxidation and reduction, right? After that, students, cross multiply the change. Whatever the change you have found in oxidation and reduction, you have to cross multiply the change. Like the change you have seen in reduction, you have to multiply it with the atoms of the oxidation. The change you are seeing in oxidation, you need to multiply with that in the reduction. Don't get confused that, ma'am, so many rules, we will forget. No, you won't. In the questions, I will make you understand one by one. Just for the sake of your notes, I have written in one form so that you can write in your notebooks, right? After that, balance all the atoms except oxygen and hydrogen. Now, whenever you are balancing all the atoms except oxygen and hydrogen, what you need to do is count oxygen atoms and add water accordingly to balance the oxygen atoms. Clear? After that, students, when oxygen atoms are balanced by adding water, you need to balance the hydrogen atoms by adding H positive ions. Now, students, this was the case for acidic medium, but whenever there is a basic medium, you need to see that add same number of OH ions on both of the sides, which is equal to H positive ions added. Now, one by one, what we are going to do is these steps we will follow, and I will let you know how to do questions. So you have one question in front of you. Let us write this question. Okay, let us write this question. H2SO4 again, it's a thick, so I am taking it thin, right? Okay, so H2SO4, students, plus HI gives H2S plus I2 plus water. I have not written XYZ. Why? Because first I'll let you know how to do these kinds of questions, and then we will calculate the value for X, Y, and Z. So students, what you need to do is, first of all, you need to write the chemical equation, which I've already written. Now coming back, see the next step. Write the oxidation number on each atom in a reaction. Now, first of all, write the oxidation number. We know that hydrogen's oxidation number is +1. Sulfur's oxidation number we will calculate. Okay, let us calculate here. H2SO4, hydrogen is +1. There are 2 hydrogens. Sulfur is taken as X. Now for oxygen, we take as -2 into 4 is equals to 0. So it is 2 plus X minus 8 is equals to 0. X is equals to +6. Now what is the oxidation state for sulfur? It comes out to be +6, students. Clear? For sulfur, it is +6. Now, if I talk about oxygen, it is -2, right? Here, it is +1. For iodine, it is -1. Iodine comes under the family of halogen groups, right? Here, if I talk about hydrogen, it is +1. Now, for sulfur, we can again calculate here. Okay, for H2S. Hydrogen is +1. They are basically 2 hydrogens. For sulfur, let us take as X, and it is equals to 0, which is our what algebraic sum is totally equals to 0, right? So here 2 plus X is equals to 0. X comes out to be -2. So here in the case of H2S, sulfur's oxidation number is -2. I2, it will be 0 because iodine is bonded with iodine, the same atom. Now for water, I would say it is +1 and -2 respectively, right? Now students, whenever you're writing a reaction and you find water in this, kindly do not consider it first. Why I'm saying that, you will say that ma'am, it is given in the question. Don't worry, don't worry, you will get in at last in the question as well. When we are going to calculate, you will get the water at that spot. But for the first case, you need to write just the elements except water. You need to write the oxidation number. Now what we have done, we have written the skeletal equation, we have written the oxidation number on each atom. The third step is identify in which of the following oxidation and reduction occurs. Now we will identify here in which of the following oxidation and reduction is taking place. Now let us see. If I see here, if I am seeing, first of all, the one thing I am seeing is iodine is converted from -1 into 0. -1 into 0. Charges, I'm just looking at the charges, not looking on the numbers of atoms, like here it is 1 or 0. I'm not looking that. I'm just looking at the charges from -1 to 0. First of all, for the basic mathematics students, the students who are in, biology sections, they don't know much about maths. So this is the number line, students. Right, so this is the number line. When you are moving from this direction towards this direction, no, oxidation number is increasing. Kindly consider this. And when you are moving in the opposite direction, it is decreasing. Now just look here, it is from -1 to 0. From -1 to 0, you're moving in this direction. That means oxidation number is increasing. So what I would say, if oxidation number is increasing, hence it is oxidation. Hence it is oxidation, right? Okay, now if I talk about the other terms, like sulfur. Sulfur is coming from +6 oxidation state to -2 oxidation state. Now see, if I talk about +6, here it is 5, here it is 6. From +6 to -2, in this direction, oxidation number is decreasing. Right now, here oxidation number is decreasing. Now let us take in another color so that it is visible to you more clearly. Okay, sulfur. Okay, now oxidation number is decreasing, so it is reduction. Okay, now we have done this step also. Now let us come back. Okay, we have identified where oxidation is occurring, where is reduction occurring. The increase in oxidation number is oxidation, the decrease in oxidation number is reduction. Now the most important step, where you need to put a star mark over here, is the fourth step. That is basically find out the change in oxidation number. Also balance the atom undergoing oxidation and reduction. Right, students? So now you need to find the change. How to find the change? Just look at this case. Iodine is moving from -1 to 0. If you move from -1 to 0, this is your -1, this is your 0, this is your 1. So this is 1, this is 2. Kindly consider this as a boxes, 1 box, 2 box. So a change comes out to be 2. Right, but wait for a second. Just look here. As I told you, in the bracket, balance it also. Right, here is only 1 iodine, but here are 2 iodine atoms. So I will write 2 in front of this. Now I will do this following. Now I will do, see, for one atom, it is like 2. Kindly consider this. See, from -1 to 0 refers to as the changes. -1 to 0 is, see, -1 to 0 is one change. This box, that means it is 1. So it is 1. But for 2 atoms, it will be 2. For one atom, it is change is 1. For 2 atoms, it will be 2. Right, students? So change here, change is 2. Right, because -1, for 0 it is 1, but we have seen it was 1, it was 2. For 2 it will be 2. Now if I will see here in this case, from +6 to -2, if I see here from +6, 1 box, 2 box, 3 box, 1 2 3 4 5 6 7 8. Are you considering? Consider it as a box. From +6 to -2, the change is 8. See, here is 1 sulfur, here is 1 sulfur, so it is okay. Change is 8. Change is 8, right? Okay. Now the change here is 2, the change here is 8. Are they divisible by each other? Yes, ma'am, they are divisible by each other. Okay. If they are divisible by each other, let us divide this on the 2 table. That is 1 will come and here 4 will come. Now the change comes out to be 1 and 4. Now the most important step, students. Now the most important step. Cross multiply the change. Cross multiply the change. Here for the reduction the change came out to be 4, and here for oxidation the change came out to be 1. Now you need to multiply this 4 number with the ones that are doing oxidation, and you need to multiply this 1 with the ones that are doing reduction. You need to cross multiply. So the 4 will be multiplied with this and with this, right? And 1 will be multiplied with these two. So what I'm going to get here, is H2SO4, it is multiplied by 1, right? Now 2HI is multiplied by 4. 2 into 4 is going to be 8HI, right? Now what it is giving us, it is multiplied by 1, that is H2S. Now what comes is I2 is now again multiplied by what? This one, 4. So it comes out to be 4I2. Clear, students? Now this step is clear to you when you have cross multiplied both of these. See here. Cross multiplication is done. Now balance all the atoms except oxygen and hydrogen. Now see, students, we have to balance all the atoms other than oxygen and hydrogen. So here sulfur is 1 on the reactant side, and the product side also sulfur is 1. Sulfur is balanced out. Okay, if I talk about other element other than hydrogen and oxygen is iodine. Here iodine is 8, but students, here also iodine is 8, that is 4I2, right? Here it is also 4I2, so it is also balanced out. Now comes the next step. We have balanced other than oxygen, hydrogen. Now we will count the oxygen atoms and add H2 accordingly to balance oxygen atom. Now we will see the oxygen atom, students. See, here in the reactant side, basically there are 4 oxygen atoms, but there are no oxygen atoms on the product side. So where there are oxygen less, you need to add water molecules there. Here there are 4 oxygens less, so you will add 4 water molecules here. Clear? Now students, it is clear. First of all, what you did, you wrote the oxidation number for the elements, then you identified oxidation and reduction respectively. After that, you saw the change that is being occurring in oxidation and reduction. Also you balanced the atoms, right? After that, you found the change, students, and multiplied it, cross multiplied it, and after that you are balancing all the atoms except oxygen and hydrogen. After that, students, you have balanced oxygen. Where there are less oxygen, you are adding that much water molecules. So now this is done. Now let us see the next is what? To balance hydrogen, add H positive ions. Now to balance hydrogen, students, we need to add H positive ions. Here we see how many hydrogens are there? 2 plus 8, that is 10 hydrogens. But here what we see is 2 plus 8, again 10 hydrogens. Hence hydrogens are already balanced, so there is no need to add H positive. Hence this equation comes out to be a balanced chemical equation, students. Now you will say that, ma'am, but you have written one more rule here, the 9th one, in the basic medium. So this is not the basic medium. When I'm talking about basic medium, students, I will tell you there we need to add OH negative ions. So here we are not at all adding H positive, hence that condition doesn't arises here. So this is our balanced chemical equation. Now I will do another question just like this so that you can practice it. See, until and unless you won't practice, you won't be successful. So practice will make you perfect. So now coming across our next question. First of all, yes, sorry, for the previous one, they asked us the values of X, Y, and Z. So X was in front of HI. So X is 8. Okay. Now if I talk about Y, it is in front of I2. It is 4. And for Z, it is for what? It is 4. Right, students? Here X comes out to be 8 for HI. For Y, it comes out to be 4, and for Z, it comes out to be 4, students. Now moving on towards our next question. Let us see our next question, students. Okay. The next question is Cu plus HNO3 gives CuNO3 twice plus NO2 plus water. Again, just neglect water and write the equation as it is. What is the equation? Cu plus HNO3 gives CuNO3 twice plus NO2, right? Now students, what you need to do is you need to write the oxidation number for each of the following cases. Now if I talk about the oxidation number, it is 0, it is +1. I know oxygen is -2. Let us calculate for nitrogen. Let us take it as x. So 1 plus x plus minus 2 into 3 is equals to 0. X minus 6 plus 1 is equals to 0. X comes out to be plus 5. So for HNO3 students, the oxidation number for nitrogen comes out to be plus 5, right? Okay, now here if I talk about this, as I told you in the previous case, how is water molecule formed? Just like the similar way, Cu will have this number as a charge on this as plus 2 and NO3 will have a minus 1 charge on this. So now if I individually calculate for NO3, minus 1 as an overall charge on this, because the number here is 1 which has come over here as a charge, as I've told you in water molecule, just the same case. So nitrogen is taken as x plus water is minus 2 into 3 is equals to minus 1, x minus 6 is equals to minus 1, x again comes out to be plus 5 in this situation. It is minus 2, right? Okay. Now here if I talk about oxygen, it is minus 2, and if I talk about nitrogen, let us calculate it. Very sorry, students. Very sorry, students. Okay. For NO2, let us see this. If I talk for nitrogen, it is x. For oxygen, it is minus 2. These are twice. It is equals to 0. X comes out to be plus 4 for NO2, right? It comes out to be plus 4. Now, students, now what you need to do is, see, you have written the oxidation number. Now you need to identify where is oxidation and reduction taking place, right? So here if I see, Cu is moving from 0 to plus 2, right? So oxidation number is being increased. Oxidation number is being increased, as I have already told you in the previous case. As you can see, from 0 to plus 2, oxidation number is moving in this direction. It is being increased. So it is oxidation. Okay, now if I talk about another one, here what I have is from nitrogen plus 5 to plus 4, students, the oxidation number is being decreased here. The oxidation number is being decreased, which is referred to as reduction, right? Okay, now we have already identified the oxidation and reduction. Now we will measure the change. Also, we will balance out those atoms which are undergoing oxidation as well as reduction. So students, let us see here. See what is happening here is Cu is 1, Cu is 1. It's okay. Nitrogen here is 1, nitrogen here is 1. It is okay. So hence we will not multiply it with any of the atoms. Now we will calculate the change. For this, I would say from 0 to plus 2, the change is 2. The change is 2. And now for the reduction, I would say from plus 5 to plus 4, the change is 1. Okay, what we did was we will cross multiply these changes. If I cross multiply, that means this 2 of oxidation will be multiplied on the atoms that are doing reduction, and this 1 will be multiplied on those atoms which are doing oxidation. Cross multiplication we have to do. So what it is going to come, it is Cu plus. Now we have to multiply this 2 with these 2, right? So 2HNO3 gives CuNO3 twice plus 2NO2, right? Now we have cross multiplied also, and now we need to balance out all the atoms except oxygen and hydrogen. Now whenever we need to do so, let us see, we have Cu1, we have Cu1, we have nitrogen here too, but here we have twice nitrogen plus twice nitrogen, 4 nitrogen. Here it is 2, so we will erase it and we will write 4 here. 4, because we need nitrogen 4, right? So 4 nitrogen, here also 4 nitrogen are present here. Anything else other than oxygen and hydrogen? Nothing. Now we will see about oxygen. See here how many oxygen 3 into 4 is 12. Now here how many are present? 3 into 2 is 6. 6 and 2 into 2 is 4, 10. So here there are 10 oxygen atoms, here there are 12 oxygen atoms. So that means here 2 oxygen atoms are less. That means here we need to add 2 water molecule. Clear? Now whenever we are adding water molecule with respect to oxygen atom that are less, we need to find out the hydrogen here. Now in this case, how many hydrogen? 4 hydrogens are present. In this case also 4 hydrogens are present. Hence it is balanced chemical equation. This is our balanced chemical equation, students. So hopefully now you are able to do such kind of questions, right? Okay, now moving forward towards our next case, which is MnO4 negative plus Fe plus 2 gives Mn plus 2 plus Fe plus 3. Now students, first of all, calculate the oxidation number for individual atom. Here if I talk about MnO4, here if I talk about Mn, in MnO4 negative. So Mn is taken as X. For oxygen it is -2. Total there are 4 oxygen and the overall charge is -1. X minus 8 is equals to -1. X is equals to +7. So the oxidation state for Mn comes out to be +7 students. Here it is +7. For oxygen it is -2. Here it is already given, here it is already given, here it is already given, right? Now let us find out where is oxidation taking place and where is reduction taking place. So if I see Mn is moving from +7 towards +2, that means there is a decrease in oxidation number. So whenever oxidation number decreases, students, it is referred to as reduction, right? And whenever from Fe+2 it is going to Fe+3, oxidation number is increasing, it is referred to as oxidation. Clear? Okay. Now we need to find out the change. Also we need to balance out the atoms that are undergoing oxidation and reduction. So students, here Mn is 1, here Mn is 1, here Fe is 1, Fe is 1. That means they are balanced out. We need to find the change. From +7 to +2, the change comes out to be 5, right? So the change here comes out to be 5. Now, if I talk here, the change from +2 to +3, it comes out to be 1. It comes out to be 1. Very simple. Now, students, what we need to do? We need to cross multiply. That means we need to multiply this 5 of reduction with those that are doing oxidation. That means with the Fe ones. And we need to multiply that one with the ones that are doing reduction. So, what will be the equation? MnO4 negative plus 5 Fe plus 2 gives Mn plus 2 plus 5 Fe plus 3. Now, students, let us see all the atoms except oxygen, except hydrogen. Here is Mn1, here is Mn1 in the reactant, in the product side. Second is, here is 5 Fe, here is 5 Fe. So they are balanced. Now we need to see the oxygen. Here are basically 4 oxygen atoms, but in the product side there are no oxygen atoms. So we will add 4 water molecules with respect to oxygen atoms which are not present, right? Now we will see the hydrogen atoms. How many hydrogen atoms are present? So in the reactant side there is no hydrogen atom present, but in the product side there are basically 4 into 2, 8 hydrogen atoms are present. So here 8 hydrogen atoms are absent, hence we will add 8 H positive ions on this side, students. Hopefully this is clear to you. Now we will just check it out so that it is balanced or not, so that we can say that it is a balanced chemical equation. So students, now what we need to see is, we need to see, are all atoms balanced, are all charges balanced? But what we see here is, we see here that here it is 8 H positive and here there are no H positive ions. Here it is a basic medium basically. So I am telling you that here it is basic medium and here the charges, let us see the charges. Here it is positive 8 charge, here it is -1 charge, that means +1 plus 7 charge. Here it is 5 into 2, that is 10 charge. So here I can say that total 17 charge, positive 17 charges present. But here if I talk about +2 plus 3, so +2 plus 15 charge is 18 charge. Here it is 18 charge. So it is somewhat not balanced out. So what we will do is, we will add the OH negative ions. As I've told you in the basic medium, we will add on the both sides the same number of ions that we are adding as H positive. As I've told you already, there are 8 H positive, so I will add 8 OH negative on this side and 8 OH negative on this side as well. Now what here comes, let us see the situation. 8 H positive, 8 OH negative will combine to form 8 water molecules plus MnO4 negative plus 5 Fe plus 2 gives Mn plus 2 plus 5 Fe plus 3 plus 4 water plus 8 OH negative. Now students, these 4 water molecules can be moved on to this side and will be deducted. It will be subtracted, which comes out to be 4 here. Now let us balance it out again. See, charges. Now let us see the charge. It has 0 charge over here. It has -1 charge. It has +2 into 5, that is 10 charge. -1 plus 10, that is +9 charge. If I talk about here, it is +2 charge. +2 plus, if I talk about, it is 15. 15 plus 2 is 17. And if I talk is -1 into 8 is 8. So 8 and it is 17. So it comes out to be 9 students. So both of these have now 9 charges on each other. That means now it is balanced out. So you need to check out these things also, that after balancing out, are the charges equal or not. If they are not equal, then this is the basic medium. You need to add the OH negative ions on both of the sides, and hence you need to follow the question. Clear, students? Okay. Now this was all about our first method, that was oxidation number method. Now we are moving forward our next method, that is ion electron method. It is also very, very important, students. So one by one we are going to understand this. Let us see. Write the chemical equation in ionic form. That means in ions you need to write. Okay. So in the redox reaction, identify the elements undergoing oxidation as well as reduction. Now students, here is the same case as you have done in the previous. First of all, you will identify the elements undergoing oxidation as well as reduction. This is the basic thing that you are going to follow. After this, the different thing that you will see here is, now separate reaction into half oxidation and half reduction. It is a thing that is different from our first method. What is different thing here? The different thing I would say here is that first we were writing the elements, we were writing the oxidation number, we were identifying the oxidation and reduction. But now what we are doing is we are dividing both of the reactions individually. In the previous cases, we were doing all of the situations in one basic reaction. But now we have split the reaction into two parts, that is the half oxidation and half reduction. Now balance all atoms except oxygen and hydrogen. You have to balance all the atoms similar manner. Just you will separate out the situations. In the previous case, you were not separating. In this situation, you are separating. After this, now balance oxygen by adding water, the same case. Now balance hydrogen by adding H positive, the same case as done in the previous concept. Now count the electron. This is the next thing that is quite different. Now count the electron on both the sides and make two equations. I will let you know when we are doing the questions. Don't get worried. Okay. Add both the equations and get the final result. See how we are going to apply on the very first question that you have with you. That is Br2 plus H2O2 gives BrO3 negative plus water. This is the basic reaction which we are observing here. Now, some students will say, kindly neglect water. See here, what you are seeing is H2O2 is being converted to water. So you need to write the water. You can't neglect it, right? But I won't neglect water in my life also. So let me have some water till then. And you guys also have some water with you. Okay, students, now let us continue. Okay, let us see what we need to do is, first of all, we need to identify which of the following is undergoing oxidation and reduction as per the previous cases. See here. In the redox reaction, identify the elements undergoing oxidation as well as reduction. So let us identify them. Here, students, Br2 has an oxidation number as 0. In the case of H2O2, we know that hydrogen is +1. For oxygen, we have already calculated. For oxygen, let us see. For hydrogen, it is +1. Basically, there are 2 hydrogen. For oxygen, let us take it as X, and there are 2 oxygen, so 2X is equals to 0. 2 plus 2X is equals to 0. X comes out to be -1. Now for oxygen atom, here the oxidation state comes out to be -1. Okay. Now for BrO3 negative, let us calculate for Br as well. BrO3 negative, let us take for Br as X. For oxygen, we know -2 into 3 is equals to -1. X is equals to +6 -1. That comes out to be +5, students. Clear? That comes out to be +5. So here we will write +5. Oxygen is -2. For water it is +1, -2. Now let us identify which of the following are undergoing oxidation and doing reduction. So you can see Br is moving from 0 towards this +5 state. That means oxidation number is being increased. Oxidation number is being increased. That means it is oxidation. Okay. Now let us see the next case. You can see that oxygen here is in -1 state, but here it is in -2 state. That means here we can see that it is being reduction. How I can say, ma'am, it is being reduction? Let us see here. Okay. See, from -1 towards -2 in this direction, oxidation number is being decreased, right? I've already told you this thing. Okay. Coming back to the stage, oxidation number is being decreased. That means it is reduction. That means it is what? It is reduction, students. Hopefully it is clear to you. Okay. Now, students, let us see here. Now, what we are observing, we have seen the oxidation and the reduction. Now, let's see the next point. Separate the reaction into two halves. Oxidation half reaction as well as the reduction half reaction. Okay. Here I'm going to write oxidation half reaction. Here I'm going to write reduction half reaction, right? Okay. Okay, students. Now, which is our oxidation reaction? Br is converted, Br2 is converted into BrO3 negative. Now, what is the reduction half reaction? It is coming out to be H2O2 is being changed into water, right? Okay. Now, students, what we need to do is, after writing the individual reactions, we need to balance all the elements except oxygen and hydrogen. Okay, except oxygen and hydrogen. So if I see here, I have 2 bromine, but here is a single bromine, so 2 will be added here. If I talk here, there is oxygen and hydrogen, so we don't have to consider them. But after that, students, we need to balance out oxygen by adding the water molecules. So here, we need to see about oxygen. Here, how many oxygen atom? 3 into 2 is 6. That means product side has 6 oxygen atom while reactant side has no oxygen atoms. So how many water molecules will be added? 6 water molecules. See, the basic difference between the previous case in oxidation number method and this ion electron method is that in that you did everything in a single reaction, but here you have split the reaction into 2 types, oxidation and reduction. That's it, right? So here you have done this thing. Now coming towards this category, here you can see there are 2 oxygen molecules, but here there are only 1 oxygen molecule. That means you need to add 1 more water molecule here because 1 oxygen is less. So how many oxygens are less? You need to add those much of water molecules. Clear? Okay. Now after this, students, what you see is, now balance H by adding H positive. Now you will balance H by adding H positive. See here, how many hydrogens are present? Total 12. 6 into 2 is 12. But in the product side, there are no H, the hydrogens. So we will add how many? 12 H positive here. Clear, students? Now, if I come across this situation, here there are 2 H and here there are 2 plus 2, 4. How many H positive are required? Here 4, here 2. That means 2 H positive are required here. Okay, now we have done about oxygen. We have done about hydrogen. Now comes the important point regarding the ion electron method. That is, now count the electron on both the sides and make the 2 equations. This is the most interesting step. See, students. Now we will see the charges. How? See, here you see water has no charge on it, bromine has no charge on it, reactant site has 0 charge. Charge here is 0. If I talk about here charge, it has -1, it is multiplied with 2, students. It is multiplied with 2, minus 1 into 2 is -2. And here it is positive charge and 12 are present, so it is +12. How many charge? 10 charge. Positive 10 charge is present here. Here it is 0 charge. How to make them equal? If I will add negative 10 charge here, it will be equivalent to 0 charge. So what I will do? I will add 10 electrons here. I know that 1 electron is negative charge. If I will add 10 electrons here, that means 10 will be subtracted. Hence, they will be balanced out. Clear? Now, if I come across this situation, what I'm seeing is H2O2 has no charge, but this has +1 charge and it is multiplied by 2. That means here it is +2 charge. But here it is 0 charge. What will I add in this situation to make them equal? In +2, I need to add -2 so that it is equal to 0. So how will I add? I will add 2 electrons here. That means -2, hence it will be 0. So reactant and product charges will be equal. Right? Okay, now let us see what will be the next step. We have added the electrons. Now what you need to do is equal the electrons. Here there are 10 electrons, here there are 2 electrons. What to do that these electrons value will be equal? So if I multiply this whole situation with 5, then I will get 10 electrons over here, which is equal to the 10 electrons over here. Oxidation half reaction. So see what happens is my new reaction comes out to be, now 5 is multiplied with this also, 5H2O2 plus 2H positive is multiplied by 5, then 10H positive plus 10 electrons gives 5H2O plus 5H2O. Clear, students? Okay, so now what we will do, we will add both of these situations. Now let us take another sheet. We will add oxidation half reaction, and reduction half reaction, right? So what was our oxidation half reaction? Let us see. 6H2O plus Br2. 6 right hand side will be added to the right, left will be added to the left, right? 6 water plus Br2. Okay, we have right, see, this is right side, this is left side. Left side first I'm adding. Here what I'm getting is H2O2 plus 5H2O2 plus 10H positive plus 10 electrons. 5H2O2 plus 10H positive plus 10 electrons. Now comes the right side, right? If I come across the right side, I'm getting 2BrO3 negative. 2BrO3 negative. Okay. Next part is 12H positive plus 10 electrons. 12H positive plus 10 electrons. Okay. Now comes this reactions. Sorry. Now comes this reactions right hand side, that is 10 water. I can directly write 10 water molecules. So here is 10 water molecules. Now let us see which of the following is cut here. See, here is 10 electrons, here is 10 electrons. These are cut. We can move water molecules towards that side, and H positive are also moved that side, so we can move it that side. What I'm getting here is Br2 plus 5H2O2 gives 2BrO3 negative plus 12H positive was present here, 10 is moved here, so it is minus 10H positive plus 10 water molecules was present here, and here 6 were present, so minus 6 will come because it is moving on the another side, right? So what is the equation I'm getting? Br2 plus 5H2O2 gives 2BrO3 negative plus how many H positives? 2 H positives. And how many water? 4 water molecule. Now to check this is balanced or not, please check the charges. Here there is 0 charge, here there is -2 plus 2. -2 plus 2 is 0. Hence this comes out to be our balanced chemical equation, students. Okay, now let us move towards one more case. Okay, now here is another case. Cr2O7 2 negative plus Fe plus 2 gives Cr plus 3 plus Fe plus 3. Right, first of all, students, we need to identify the oxidation number for Cr in this case. Let us see that. Cr2O7 2 negative. So 2x plus oxygen is -2. Total 7 oxygen, overall charge -2. 2x minus 14 is -2. 2x is equals to 12. X comes out to be +6. Clear? Okay. Here it is +6. So from +6 to +3, oxidation number is being decreased, which is reduction. And from Fe plus 2 to Fe plus 3, it is oxidation, because oxidation number is increased. Now we need to separate out both of these reactions. We will separate out both of these reactions. Okay. Oxidation half reaction. Here is reduction half reaction, right? Now students, okay. Now students, let us see. If I go for this case, I would say oxidation is basically Fe plus 2 to Fe plus 3, right? And if I go for the reduction half reaction, it is basically Cr2O7 2 negative gives Cr plus 3, right? Okay. Now let us balance all the atoms except oxygen and hydrogen. Here there is no oxygen, no hydrogen. So we don't need to balance it out. It is one atom. Here if we see there are 2 Cr, it is 1 Cr. So 2 will come in front of this. Now after balancing other atoms rather than oxygen and hydrogen, we go for oxygen case now. For oxygen, there is no oxygen atom, but here there are 7 oxygen atoms. So we will add on the product side 7 water molecules. The next state is the hydrogen atoms. If I come across no hydrogen atoms, but if I see here in the product side, there are 14 hydrogen atoms. So we will add 14 H positive here, right? Now students, next comes the case for electrons. We need to see electrons. Here there is charges plus 2, here it is plus 3. How much charge if I add that so that the charges are equal? If I add 1 electron here, that means minus 1 charge. It comes out to be plus 2. That means 1 electron is added here, right? Now, if I come across this situation, I see minus 2 charge overall here, plus 14 positive charge here, 12 charge on this side, and on this side plus 6 charge. So how much electrons if I add so that it is equals to this? If I add 6 electrons, then it will be subtracted, hence it is equal. So I will add 6 electrons on this side. Clear? Now the next step is electrons should be equal. Here it is 1 electron, here it is 6 electrons. So what we will do? We will multiply this situation with 6. Now the new equation comes out to be 6 Fe plus 2 gives 6 Fe plus 3 plus 6 electrons. Now we will add both of these reactions. Okay, left hand side will be written on one side, right hand side will be written on the another side. So first of all, left hand side 6 Fe plus 2 plus, here it is Cr2O7 2 negative plus 14 H positive plus 6 electrons. It gives what? It gives us 6 Fe plus 3 plus 6 electrons plus 2 Cr plus 3 plus 7 water molecules. Now, the thing that are cut is 6 electrons, 6 electrons. Another thing, anything which is cut? No. Now, let us check if it is balanced or not. We will see. Here it is plus 12 charge, minus 2. It is 10. 10 plus 14 is 24 charge over here. If I see 18 charge here, 18 and plus 6 is 24. So it is balanced chemical equation, students. This is our balanced chemical equation that comes out in this situation. Clear? So students, this was all about ion electron method. Now we will proceed towards our next topic. So students, now we are proceeding towards our next segment, that is equivalent weight and N factor. Basically, what do you mean by equivalent weight or N factor? N factor of oxidizing or reducing agent is equal to number of moles of electrons either gained or lost by 1 mole of a substance. This is the basic definition for N factor, I would say. Now, what is the formula to calculate equivalent weight? Equivalent weight is equals to molecular weight upon N factor, students. Now, this is the formula that you're going to use in some of the questions to calculate equivalent weight. If I consider some cases, for example, if I talk about KMNO4, students, here you can see that there are 3 cases that arises in KMNO4. One is in acidic medium, another one is neutral, and the third one is alkaline. So if I talk in acidic medium, KMNO4 is converted into Mn plus 2. Now, what will be the N factor here, students? First of all, we will calculate the oxidation state for Mn here. I know that for potassium it is +1. For Mn, I am going to take it as X. For oxygen it is -2 and total 4 oxygens are present. So all I would say it is +7 oxidation state. Now what will be the N factor here? N factor is the number of electrons lost or gained by 1 mole of a substance, as we have already seen the definition. So from +7 to +2 it is N is equals to 5. So what will be the equivalent weight? Equivalent weight will be equal to molecular weight divided by N factor, that is going to be 5 for this case. Now if I talk about neutral, students, that means if I am talking about when KMnO4 is converted into MnO2. For this case, let us see the oxidation states. Now for it, again, I have already calculated it's +7, right? For MnO2, let us calculate. X plus oxygen, it is -2 and 2 oxygens are present. So it comes out to be +4, right? Right. So here +4 is the oxidation state. Now again, if I talk about N factor, from +7 to +4, it's 3. So N here comes out to be 3. Hence, equivalent formula weight will be molecular weight by 3. Right, students? Now if I talk about the third case, that is the alkaline one, in which KMnO4 is converted into K2MnO4, where we can say in KMnO4 it is +7 oxidation state of Mn. While if I talk about K2MnO4, here we can calculate for Mn. It comes out to be, for potassium it is +1, and for 2 potassium it is +2 plus X, plus for oxygen is -2 into 4, it is equals to 0. Now to calculate, 2 plus x minus 8 is equals to 0. X minus 6 is equals to 0. X is equals to +6, students. So what we see here, from +7 to +6, that means N value comes out to be 1. Now equivalent weight will be equal to molecular weight upon 1. So by this thing you can calculate for different cases the values of N factor, and further you can calculate equivalent weight. Let us take one more example, students. For the case of K2Cr2O7, here students only acidic medium is seen, so the conversion is from K2Cr2O7 to Cr+3. Now what happens is, let us find for Cr here its oxidation state. I know for potassium it is +1 and 2 potassium are present, so I will multiply it with 2, and for 2 Cr I will write 2x. For oxygen, I know it is -2. 7 oxygen atoms are already present here. So I would say 2 plus 2x minus 14 is equals to 0. 2x minus 12 is equals to 0. 2x is equals to 12. X comes out to be +6. So what I have seen is that for Cr2, +6 oxidation state is being converted into +3. But for twice, it will be converted how much? From +6 to +3, it is 3. But for 2 molecules, it will be 6. So here, N factor comes out to be 6. Hence, I would say equivalent weight comes out to be molecular weight upon 6. Clear, students? So this was the way to calculate equivalent weight and N factor with the help of electrons gained or used in 1 mole of substance, right? Now comes, students, our last topic, that is titration. What do you mean by titration? Basically, titration is done to calculate the concentration of a particular substance. Okay, to calculate concentration of substance. Now how we can do so? Students, we take basically two equipments here. What do? We take a burette, right? And below the burette, we keep a beaker. Basically, this beaker is used below. In this situation, a conical flask can also be taken instead of beaker. Now, what happens is, why do we use burette over here? Why don't we use directly a flask and put the substance from this area towards the conical flask? The reason is that because whenever we put directly a substance into the conical flask, the temperature can rise up, and so the heat can be produced. So, one by one, that means drop by drop, we need the substance to move towards the conical flask. So to do so, we use burette so that we could handle it from this side so that the drops can move one by one and would move inside the conical flask. Now what happens is, for example, we are taking a solution here in the beaker, which is a colored solution, right? and the solution, when we have opened the flask like this and drop by drop the level of the drops are going inside the conical flask, what happens? As soon as the drop touches the conical flask, the material that is present inside it, the redox reaction starts. Now the question arises, until when the redox reaction will be carried forward? So the answer to this question is, we will use an indicator. Basically what happens is, whenever, for example, I'm using potassium permagnetate, its color is purple, right? So when drop by drop it is moving into the conical flask, the purple color get colorless. One drop goes, it get colorless. First it was purple, then it became colorless as soon as it touches the solution inside the conical flask. This kept on going on, but at a particular stage, what arose? When the solution went into the conical flask and it didn't turn out to be colorless, it remained same from purple to purple. At that spot we get to know that the reaction is complete, the redox reaction is complete. So we can calculate at that spot the concentration. Now how can we calculate, students? For example, it has something molecularity as m1 and the solution has volume v1. Now volume is being given to us, okay, and we need to calculate the molarity, that means the concentration of the solution. So how we can calculate? We can calculate with the help of number of moles. Further we can calculate with the help of molecularity formula, which is number of moles divided by volume of solution in liters. Further, students, as we have already done equivalent weight topic, so with the help of equivalent weight we can calculate the concentration of substance which is present inside the beaker. So this was all about titration. That was a little bit basic concept which you can use with the help of equivalent weight, right? So yes, my dear students, hopefully you have got all the topic very clearly, you have understood all the topic very clearly. But one thing I would just say to you, if I fail, I try again and again and again. If you fail, are you going to try again? My question is, if I fail, I try again and again and again. If you fail, are you going to try again? The human spirit can handle much worse than we realize. You know that? It matters how you are going to finish. Are you going to finish strong? Students, I want, a teacher always want its students to finish everything very strongly. Whenever you are having any situation in your life, any problem in your life, whether you are solving any question, you are unable to do so, whether you have attempted a test, you are unable to crack it, or whenever you are practicing, you are unable to use the concept of what I need to apply here, then just you need to remember that you can do anything. You are stronger, you can do, you have that ability that you can achieve what you want in your life. So you have to make yourself so much strong that you can see the situation by your eyes like this and say, I can do and I will do. And I know my students will always achieve. Right? So yes, my dear students, hopefully you have done this chapter very nicely with me. I just want one thing, that do solve DPP questions, do practice more and more questions from different books, so that students, you could see that how the concept is applied to the question work. It may be that once or twice you are unable to attempt the question, but again I'm saying you are stronger, you can do. Learn from the mistakes that you do the first time, then learn from the mistakes that you do the twice time. Do this, and once when you know your mistake, you will solve the question by your own very perfectly. Do follow all the concepts. If you have any problem, revise the concepts, review the video again and again so that you can understand the concepts very clearly. So I will meet you in the next lecture. Till then, keep smiling, keep learning. Thank you so much.